Hi, I'm Nas. I'm the CEO and founder of Rebel and the author of Developer Life and the maintainer of the Rebel 2-week crates. I believe that open source comes from an open heart and from the joy of coding. In today's video, we're going to talk about, actually, I'm going to show you a bunch of configuration settings that will help in alleviating the build times, the compile times for Rust. So like one of the biggest sort of downsides of Rust is the slow compilation or build times. This is a known problem. I mean, there's a lot of reasons for it, but recently I found a lot of interesting tools that are available and also configuration settings that have been made available in Rust itself to actually improve this whole situation. So roughly, we're going to be talking about this RUSTFLAGS Z threads equal 8 configuration. This one gave me the most sort of bang for my buck. This was fantastic. I'll show you how to configure this on a, either you can do it globally or you can do it per project. This other one was actually telling, I use Rust Analyzer, I use VS Code, I also use Rust Rover, but in the VS Code, and I use Claude Code, and Claude Code also uses Rust Analyzer with Serena MCP. So in order to, what was happening is that as I had all these tools running, there was a lot of contention in build times because they were all targeting the target directory when they would acquire lock on the target directory when they were building artifacts. And I also have like Bacon running, so every time a file changes, it kicks off this massive workflow in my project. So there's actually a really cool feature in Rust Analyzer that allows Rust Analyzer to maintain its own target directory. That ended up making my terminal-based build tools run seamlessly with the stuff happening in VS Code. And then Rust Rover does its own thing, so it wasn't even affected by any of this anyway. And then another one am using, I'll show you how to do this, is sccache. Yeah, sccache. It's made by Mozilla, and this is actually really good. It takes up more disk space, so if you have a lot of disk, this is totally worth the trade-off. And then the while linker, specific to Linux. So I am on Linux, so I'll show you how to do that. And then I can share some other insights. There's actually, you can use something called Cargo Next Test, and it's actually way faster than Cargo Test because Cargo Test runs all the tests. It takes the tests, puts them in a binary, and then spawns a thread for each test, so I can run them in parallel. Cargo Next Test, so you can have global space pollution because they're all in the same process. Memory space, global memory space, if you have shared global memory. Mutable shared global memory. So with Cargo Next Test, it actually spawns each test as a separate process, and it runs way faster. So I would recommend using this. And then, let's see. Oh, and I also have some really cool script that I just made for configuring the nightly builds, because I'm actually on the nightly toolchain. And I was having some severe problems where nightly was breaking Clippy, and that was problematic. So I'm going to put this here. So this is, I'm going to say smart nightly toolchain updates. So I will share that as well. Okay, so to anchor the, yeah, so with that, I'm going to start from the beginning. So the first thing I'm going to do is I'm going to use a Rebel open core repo to actually demonstrate. Do I have a link to this? Yes, I do. I'm going to use this as a way to demonstrate. It's this repo. So let me go back to this. It's this one, Rebel open core. So it's a Rust text user interface library, which does a lot of things. You can read about it here, but specifically, I'm going to be focusing on this for today. So this is a nice example. I mean, you can get this repo and then just copy the settings and apply them to whatever your project is, or you can make them global. But yeah, this is the project I'm going to be using, and so I will there's the build cache one and a whole host of other things, while linker, and a whole host of other, like if you've never seen Bacon or if you want to use Bacon, there's some cool stuff here. And I even have some interesting, if you use a GNOME and you want to monitor your build status in GNOME, there's a way to do that as well. So there's all kinds of interesting stuff, but I'll keep it focused to just the compiler speedups for today. So let me open this, and okay, so this is the, well, there's the README that we're looking at here, and so let's go look at the Rust Analyzer settings. So this is, the use case for this is, you have, so every time you have, like, let's say a project open in VS Code, it's spawning a Rust Analyzer, and you can see it actually, you can see it in here. So you can see Rust Analyzer. So these are, oh, let me just hide the, what is this, 2, okay, wow, 3, yeah. So here you can see, like, there's a whole host of Rust Analyzer instances, like quite a few actually, and they're not all, they don't all belong to this VS Code Insiders instance, because I also have like VS Code running. I have Claude Code running. Claude Code uses Serena MCP. Serena MCP uses Rust Analyzer. That's why there's so many instances. So they end up taking a lot of RAM, but fortunately, they don't really slow things down. This Rust Analyzer is really good. So one of the things that was happening is that because Rust Analyzer, every time I'd make a change, Rust Analyzer would, you know, do its analysis, and it was slowing down to the point where my VS Code was laggy, like significant, like I was like, I could not understand what tools were causing this problem. There's two things that fixed it, but one of the, I'll show you the first one, which is this one. So the fix for this is very easy. So you go to Rust Analyzer, and it's literally just this line. It says Rust Analyzer cargo target directory. And by the way, if you wanted to learn more about what this setting actually does, there's more information here, and also there's a really good article on the Rust compiler performance survey, where there's a whole bunch of stuff that you could do. This is not comprehensive. I have more stuff that I'm showing you than what I found here, but this is where that came from, the whatever, VS Code slowdowns because of Rust Analyzer. So anyway, there it is. So it's optional path to Rust Analyzer specific target directory. This prevents Rust Analyzer cargo check and initial build script and proc macro from locking at the expense of duplicating build, which is fine. And so this ends up making it so that you can have Claude Code running with Serena MCP. That's got Rust Analyzer, but that's going to be using your target directory. This one, on the other hand, is going to be VS Code is going to be using its own target directory. And what it looks like is, if you look here, so in the target directory, normally, you know, there's my artifacts, right? But also, if you look, there's another Rust Analyzer. I mean, not another. There's a Rust Analyzer folder, which is where Rust Analyzer itself is keeping its stuff. So flight check is what it does when it does cargo check. So there you go. So yeah, it'll take up more disk space. So let's see how much disk space. What is this target? What is this? Unexpected argument. I didn't give you an E. So 3.5 gigs, and then if I do Rust Analyzer, that's not too bad. So whatever, it adds about roughly a gig. So it's not that bad. It's totally worth it for VS Code responsiveness. So that was it for the first one. That was very easy. So again, when I have VS Code running and I was spawning a Helix as an example, Helix and VS Code would hit the same. Their Rust analyzers would hit the same target directory. Now VS Code hits its own target directory. Helix hits the normal one. I have build tools running all the time. Let me show you. So I have cargo next test running constantly using Bacon. I have cargo doc tests running using Bacon. I also have cargo doc building constantly using Bacon. So these are hitting the normal target directory, so when they do their checking and building, they're not in contention with VS Code. So that's basically it. Okay, so that was easy. Moving on to the second one. This is the most significant, well, one of the most significant, I would say. If you just do the first two, I think you're well on your way there. These others help, but this is like significant chunk of the improvements come from just the first two. So this is the Rust flags. So you can either configure this globally, but I decided to configure it. Where did I put it? Let me put all the TOML files. TOML files, Rust toolchain, Rust format. I think it's config TOML. Let's open this one. Yes. So in my config TOML, which is scoped to this particular project, I have RUSTFLAGS Z threads equals 28. Wait, what? 28? Okay, that's too many. It should be 8. Oops. So 8 is a sweet spot. More than 8, less than 8 doesn't work so good. I don't know why it said 28. That's definitely a, wow, I'm glad I found this while making this video. So yes, note it should be 8, not 28. And if you don't want to do it here, and you want to make this available to everybody, you could put in your bash RC, or you can put in your profile, so .profile. So it depends, like if you want it when your graphical interface starts, then anything spawned from that graphical environment. So for example, if you click on a toolbar or launcher dock, and you want this setting to be in your environment, then you have to set it in profile. If you only launch your development tools from terminals, you can just put in your bash RC or config fish. Or you can do it this way, and it doesn't matter. It just scoped to the particular project. So cargo will just pick it up from here. And that's it. It's that simple. So totally worth it. Try it. I think it's pretty incredible how quick things get with just these two. And again, this one you won't see a difference unless you have contention from multiple IDEs like VS Code and Helix or VS Code and Cloud Code. That's not an IDE, but something else that's using Rust Rover that's also pinned to that target directory. Okay, so let's go to the third one. This one requires a little bit more configuration, but what you can do is just, I mean, you don't have to do this, but go look at the Bootstrap shell script, and it has, you can run it. It's non-destructive, and it's idempotent, so you can run it over and over again. It won't, if it's done something already, it won't do it again, and it won't destroy anything that it's done before. But in here is information on how to install sccache. So, where's sccache? What is this doing? Oh, this is actually generating the cargo config. Nope. Or maybe it's actually I also have run fish. Maybe it's here. What is this? Install cargo tools. Maybe it's here. Oh, it is. Okay, my bad. So Bootstrap won't. You can run Bootstrap anyway. It installs all the dependencies that the install cargo tools function takes. So you can just say, if you have fish installed, which Bootstrap will install, then you can say fish run fish install cargo tools, and it installs sccache and a whole bunch of other stuff. But Bacon, if you want it. Cargo next test, and on and on. But yeah, sccache is the one that we're interested in, and this is the command that, or you can just run this command, cargo install excuse me. You can just run cargo install sccache -- locked. So that works as well. And once you have it installed, it pretty much, you're done. It configures itself. It's automatic. You don't really have to do anything, and just make sure it's installed. I don't think it modifies anything. And once it's installed, you'll get these These are just aliases, but let me show you. So once you install sccache, then you'll get an sccache binary. So like it's home, whatever, it's in cargo install. Or you could do cargo install sccache. You don't have to build it from source. But yeah, so then you could see sccache show stats, and it'll show you like, as you can see, this is my build cache, and it'll show you how much disk space it's using and all that stuff. So this is totally, and you can see like how many compile requests have come in since I cleared the cache. So it actually starts as a service. It's pretty cool. It's really, really well done. This works really well. It's basically no configuration. Yeah, so one thing, if you do use sccache, you can also do this sccache clear. You shouldn't have to do this manually, but you can if you want to. So what I've just got aliases to do this, but what it is sccache 0 stats stop server, and then that basically next time it destroys the sccache folder. Next time you say cargo build, it will restart the server, and it'll just keep running. So it's really well integrated into cargo. Okay, so that was easy. sccache, just using a bit more disk space, and you can also distribute this. So if you have multiple machines that are building these artifacts, you can actually have see this. My sccache folder is local, but I can actually easily make this a network share or something, and sccache is able to handle distributed build caches. So that's another nice thing if you have a complicated setup. Okay, while linker, let's look at this. How do you install while linker? I think, let me see, is it here? Install while linker via cargo binstall. Oh, that's another interesting. Oh, so it's cargo binstall. Okay, so it's just, you just install it using cargo. So cargo binstall while linker or cargo install while linker. And that, it looks like, let's see, cargo config toml. That doesn't have any configuration. I wonder if there's any configuration, because it looks like, what is this doing? Adding to configuration, cat cargo. Oh, okay. So while linker has more configuration than anything else. Well, maybe the rust flags, whatever. There was some configuration in the in that toml file. But this thing, if you notice, there's a .cargo config toml. So let's go open that. And that is in the .cargo directory, which is specifically for wild. So if you run bootstrap, it will generate this for you. And I wonder if, hey, it got the threads right here. Interesting. I wonder how I messed that one up. But yeah, so you have to like replicate. Actually, I wonder if you need both. Like if you have this config toml here, do you still need that other toml file we opened? Where was it? What the heck? Let me see. Docs TUI. That's bacon configuration. No, that's not it. Config toml? Interesting. I think this might be redundant. Let me double check. Let us ask Claude. So let's see. We have both. What is this? Config toml. And what the heck? I have both config toml and config toml files. Which is used? Does one have precedence over the other? Should I just delete the root level one? Because that seems like that, because that had the wrong settings, the 28, and I don't know if that was working. So let's ask Claude and see if it can come up with an answer. Pretty sure we could just delete this. I think this was a mistake on my part. But we'll know in a second. But I guess I should put here while linker needs actually you can make this change in .config. Is it .config? .cargo config tomo. And I think this one also while linker. Yeah, okay. At least now it'll be in the this is the issue tracking this video, so I'll post a link to this in the description of the video. Okay, looking at your two config files, I can clarify. Only that's what I thought. Okay, is ignored. Excellent. All right, so that was a mistake, and I will delete that file, which is good because it had the invalid setting of 28 threads. So, oops. Must have been while I was working on the stuff. Somehow randomly it got added there. But anyway, there you go. So if you want this auto-generated, just run Bootstrap. It'll do it for you. Otherwise, you'd have to, essentially, you have to replicate. The only weird thing is that whatever you put in the top level, you have to like copy it over again inside of this target. So this is just, it's a thing. So unfortunately, this is repeated. This is repeated here as well. So anyway, so that's how you get wild, and that doesn't speed up the compiler, it speeds up the linker. So when you do cargo check, this will have no bearing. Cargo check will go blazingly fast as soon as you put this in there. The RUSTFLAGS threads equal 8 or whatever. And also, depending on if you run cargo check in multiple places, if you have, in my case, VS Code and terminal, so this is my this thing is running cargo check all the time or whatever, or if I have Helix running, then yeah, you definitely want to do this. But so I hope that's clear. Like this will have zero impact on your build times if you don't use VS Code and if you don't have multiple Rust analyzers locking on that target directory. So yeah, okay. So that's while linker done. Oh, and this is just some bonus. This isn't really going to speed up your build time, but you could actually use where is this? I think it's here. Cargo next test. Yeah. So if you install cargo next test, or you can use cargo install, whatever's good for you. Yeah, this one when you run cargo next test run, it's way faster. Compared to cargo test, but it does not run doc tests. So that is why I use Bacon, and in Bacon I have some tasks that I've created. These are Bacon tasks, and one of them runs all the tests in cargo next test. Then it separately runs all the doc tests, and then separately runs it builds the docs. Like so cargo test doesn't build the docs, but cargo test does do two of the things that next test only does one of them. So like Rust docs in your source code, cargo next test ignores. It only runs the tests that are explicitly marked as tests, not doc tests for some reason. And then I think that's okay. And one last thing. This is just completely optional. I'm on the nightly toolchain, and because of reasons, many reasons. And I was having some issues upgrading to the nightly and finding that getting all these ICE errors, Rust compiler errors, and so like cargo clippy would flake out, or I'd have weird lint problems, and stuff would break, and it was just it was just disrupting my workflow quite terribly, wreaking havoc. Yeah. So I make this script toolchain. And you can find it in, oops, this one, Rust toolchain up. It's a pretty lengthy script, but essentially what it does is that it looks 45 days behind from today as its window of candidates. And it just goes through and downloads the oldest toolchain first, sees if it works by building the whole code base. It runs cargo test, it runs cargo, it does the tests, the doc tests, it builds the docs, it runs Clippy. And if they all are verified as it's good, then it'll say, okay, cool, we've got you a toolchain. And so I run this script. I can run it every day. I can run it every week. I have systemd configured to run it every week, I think. But you can run this every day. It doesn't matter. So this way, if it finds a toolchain, like as it's going through its window, if it finds one like 45 days ago that's bad, then it will go 44 days ago. If that's bad, it'll go 43 days ago. If that's bad, and so on and so forth, until it finds something that's stable. So what the logic is that the closer you are to today, potentially it's more unstable. We could go the other way, actually. We can invert it. We can say start today and go backwards. For whatever reason, I'm biasing the oldest toolchain to be the most stable. I don't know that that's valid reasoning on my part, but maybe I'll flip this script later. But yeah, that's what this script does. So this is something that I've been using for a little bit now, and it's really nice. It's yeah, that way you can have your nightly and not have your compiler errors too. So yeah, this is a pretty short video. That's all I have. Hopefully these tips and tricks will help you boost your developer workflow, because I mean it can be quite, it's not cool when especially cargo check is just freezing your system or whatever. And this the code base, I think, it's about 100,000 lines of code so far. So it's not a small code base, not the largest code base, but you know, I've seen significant improvements. I couldn't go back to not having these. Let's put it that way. Yeah, with that said, if you like this video, please give it a thumbs up, subscribe to our channel, and yeah, if you like this style of this video, let me know in the issue, and I might do more sort of configuration videos. I have another one I'm going to do on Ubuntu configuration, and then I'll do another really awesome one on getting rid of off-by-one errors using Rust type system design, the new type pattern, all kinds of cool stuff. With that, thanks for watching and have a great day.